This is the Unit 7 Targets 3 and 4 homework out of the book. This was on page 25, number 27. It says find the distance between the 2 points. J is at -8, 0, and K is at 1, 4. I'm going to show you both strategies from class because we want you to be able to use both strategies. J is at -8, 0. K is at 1, 4. So there's the line segment JK from -8, 0 to 1, 4. And so the first strategy we talked about in class is that you can create a right triangle and use the Pythagorean theorem. So I can create a right triangle by just drawing over and up, and then I can count the boxes. So on the bottom of the triangle I have 9 boxes. On the vertical, or the right side of the triangle, I have 4 boxes. And so using the Pythagorean theorem, 4 squared plus 9 squared is going to be equal to my distance squared, or I could say d squared. Your book might also use the notation JK squared. JK is the length of segment JK. So 4 squared is 16, 9 squared is 81. 16 plus 81 will give you 97. And so the distance, which is the segment length of segment JK, is going to be the square root of 97. We then want to try with our calculator to see if we can break 97 down into any perfect squares. 97 doesn't divide by 2 or 3. Since it doesn't divide by 2, it doesn't divide by any of the even numbers. 97 doesn't divide by 5 because it doesn't end in a 5 or a 0. I could try 7, but that does not work. 97 divided by something like 13, it does not work. 97 divided by 11 isn't going to work. So 97 does not have any perfect square factors, and so my answer is just the square root of 97. If I do this with the distance formula, which is the same idea, I'll show you that the 9 that we got on the graph by counting from -8 over to 1 is the same thing I'll get if I take the x values, -8 minus 1. That gives me -9. So -8 minus 1 squared, just like we squared the 9 squared in the Pythagorean theorem. We took 9 and squared it. The 4 for the vertical component was squared as well. The 4 comes from 0 minus 4 squared. So using the y values. In the Pythagorean theorem, we added those two sides together. So we're going to add those two sides together. And then that was equal to our distance squared. So to get the distance, we're going to take the square root of -9 squared, which is always going to be a positive number because a squared number is always a positive number, plus -4 squared. And that's going to equal my distance. So again, I'm going to have the 81 plus the 16 that's equal to the square root of 97, which is d. So the distance formula comes from the Pythagorean theorem. If I wasn't looking at it as a graph, I would have set it up. And so the distance formula, x2 minus x1 squared plus y2 minus y1 squared. In this case, I was using -8 as my x2 and my 0 as y2, and I was using the 1, 4 as x1, y1. It does not matter which one is the first or the second, as long as you're consistent from point to point.